Disclaimer: I am not an expert in coding. I am teaching myself Python for data science, and I'm sharing what I've learned with all of you. So let's start at the very beginning. I am using Google Colab, which is a cloud-based notebook for coding. When you open up a document here, it will automatically be saved in your Google Drive. It'll create a yellow folder that says Colab Notebooks, and every document will be put in there. So first, let's look at a couple different settings. If I click the settings icon over here, one thing that you're probably going to want to turn on, if you go to Editor, make sure that Show Line Numbers is checked. That's going to make it a little bit easier to talk about certain lines of code. That's the main thing that you're probably going to want to change. You can scroll through to some of the other settings if you want to, like you can turn on corgi mode so that there will be corgis that walk across the top of your screen, which just makes everything a little bit better. Next, in this blank document, there are two different types of cells that you can create. You can do a coding cell or a text cell, and each of these boxes here is a cell. If I want to add a text box, I can write some notes about what my program does. So I can say, little note to myself that this has some basic things about Python. If I want to rearrange the cells, I can move this up or down using this little toolbar over here, or I can delete it if I decide that I don't want that. This is a coding cell. This is where you type your code. When you type your code, first, nothing is going to happen until you click this little play button here, which is the run button. Or if you want to not have to click, you can use Control Enter to run the code that you've written in that cell. If you go to the runtime menu at the top, you can click Run All and run all of the code in your entire document. But depending on how much you have in your document, that might take a little while. So let's get started. Traditionally, the first thing that you code when you start coding is hello world. When you are coding, couple of things. You can type a comment, and to do that, you start with a hashtag, and that will put things in green so that you can write little notes to yourself or notes to other people throughout your program. So I can say, this is a comment in my green font with the hashtag. To actually type hello world, I can't just type hello world. I have to use a print statement. This tells the program that I want it to output some text. So I can say print. Okay, that's a command, and then it's going to print what's inside the parentheses. But I do need to put it in double quotes. Now, if I click the run button, eventually, there we go, it will output my text. So I'm printing out the statement, hello world. So now that we've done that, let's add in more text. If I want to say something like, hello world, my name is Caitlin, I can continue typing all of that inside the quotes. Or if I want separate statements, I can use the comma to say I want you to print the first statement in quotes and then the second statement in quotes. So I can say inside the second set of quotes, my name is Caitlin. When I use this comma, it will automatically put a space between the two statements that I have put here. So when you're coding, you can either continue coding everything in one coding cell, or you can break it up and say, okay, it's a new topic, so I'm going to start a new coding cell. That's totally personal preference, whatever makes sense to you. There are several different types of variables, and sometimes you need to specify what type of variable you want something to be. The four that we're going to start with are string, integer, float, and Boolean. A string is going to be text. An integer is the same as an integer in math. It's going to be numbers like -4, 0, 12. Those are all integers. Float means you're using a decimal. And then Boolean is true or false. So if we are going to define our variables, variables must start with either a letter or an underscore. So we can write a little note to ourselves. An underscore. Okay. So I'm going to define some variables, and I'm going to use characteristics of my dog, and then I'm going to reference some of these variables. So I can say dog name equals, and my personal preference, I like to put spaces before and after the equal sign because that just works better with my brain. It doesn't really matter. You can not put spaces as well. So my dog's name is Audrey. This variable is a string. I have stored text as the variable dog name. Age, she's 10. So this variable is an integer. Her breed is a border collie mix. Again, this is a string. Now, you do not have to put comments of what variable type your variables are. I'm just doing this so you can see different examples as we're going through these. Her weight, last time she went to the vet, was 41.2 pounds. So this is going to be a float variable because we have a decimal. And then I'm going to do is, I don't really want to write out the whole word vaccinated, is vax. So this is going to be either true or false. This is true. So this is an example of a Boolean variable. Okay, so here we have several different examples. Now, I can write print statements or I can do math referencing several of these variables. So I could say I want to print dog name, and sometimes this gets in the way, go away please. So whatever I put as the dog name, then you have to put a comma next, otherwise it's going to have some issues. Then I'm going to use the text is, oops, and then for weight, and then that's in pounds. So when I hit run, it is going to store all those pieces of information as those different variables, and then the only thing I told it to do was do a print statement. Audrey is 41.2 pounds. Okay, or I could reference any of those variables in that statement. Now let's continue with some other basics. We can do, since this is a new topic, I'm going to use a new coding cell. Let's look at some basic math. Now, a lot of the math symbols that you normally use still work here. there is one that's a little bit different, and that is an exponent. But addition, subtraction, multiplication, division are all exactly what you would expect those symbols to be. Now, we can also assign numbers as variables just like we would on a graphing calculator or in Desmos. So I'm going to say a equals 3 and b equals 4. These are my two variables that I'm going to do math with. Now, if I just say a plus b, it's not going to do anything. I need to tell it to print that output. So let me hit run here, and it's going to output 7. But it doesn't tell me what that is. If I want it to have text, oops, go away, and do that. Okay. I need to add that text in so that I know what it's calculating. So addition is as you would expect. And I don't want to write this a whole bunch of times, so I'm going to copy and paste this. Subtraction is just the minus. Multiplication is the asterisk. Division is the slash. And then the one that's weird, the double asterisk. I'm going to do it this way. Is the exponent. So now I can output all of these math calculations. 3 plus 4, 3 minus 4, 3 times 4, 3 divided by 4, and 3 to the 4th power. Now, if I decide that I don't need these calculations anymore, I can comment out these lines. So all that means is after I've done the math, instead of deleting them, I'm just gonna make them a comment and say, I don't actually need you to print this anymore, but I don't really want to delete it. So now it's going to skip over that line of code. So I'm going to go ahead and comment out all of these. And then let's look at some more examples. If we think about algebra, one of the things that you do a lot in Algebra 1 is plug values into equations. So I can say, all right, let's think back to Algebra 1, y equals mx plus b. Let's say that my slope is -1/2. I already have my b value above, so b is 4. Let's just keep that. And then say, all right, maybe I want x to be 8. If I'm plugging 8 in for x in y equals mx plus b, what does that equal? So I can say y equals m times x plus b, and I want to print y. I can go back and change this value of x, and it'll change there. Now, that might not be the most efficient way to plug in a bunch of values for x. So there is actually another option here. I'm going to add another coding cell. And we are going to look at how to do user input. So I'm going to use the same values we just had. M is -1/2, B is 4. Now, I'm going to say x is going to be some value, which could be a decimal. I want to use the input function, and it's going to give a prompt that says x value. So let's see what this looks like. It's going to give a box that says X value, and then you type something in there. All right, I'm going to stop that. I know there's an error. We'll ignore it for now and continue. So then I want to take y equals m times x plus b and print y equals whatever the value of y is. So now it gives me my box, and you can see this little caret here that says we are currently on line 4, we are awaiting input. So I'm going to say x equals 12. Hit enter, and then it continues with the rest of the code. Plugs it back in, figures out what y is, and then prints that value. You might also notice that the number 12 is really close here to the word value. I can fix that by just adding a space after the value there. So I can try this again and say, what if x is negative 2.7? And then it gives me my y value. So this works with numbers or with strings. The default is actually that whatever you input is stored as a string. I had to force it to let my value be a number by using this float in front. You could also put int in front if I know that I only have integers. So let's look at an example with text. So I can say name is going to be user input. What is your name? Oops. And then I can print hello name. So you can use that input function anytime that you want people to type in a value, and it could be a string or a number, either a decimal, a float, or an integer. One last thing I want to look at, if we go back to some mathy things, oops, let's look at comparing some numbers. So if I say, let's go A is 3 and B is 4 again, I want you to tell me, is A equal to B? Okay, the double equal sign asks, are these equal? That's what that's doing. And this will output a Boolean result, either true or false. There are several other options here. You can do a less than B, which asks, is A less than B? You can do A greater than or equal to B. You could do greater than and less than or equal to as well. Okay. But those will ask the question, is this true? And give you either true or false answers. Again, if you want it to print the question that you're asking or the calculation that you're doing, you need to add in is A equal to B. And then it'll output the result, which is false. So those are some very basic things about how coding works in Python. We will add in more things as we continue throughout the semester, but those are the absolute basic things that we are going to build upon as we move forward.